Hey, good day folks. This is the third video in my series about terminal games where we implement a game of Snake in Zeek. So in the previous video we looked at terminal graphics where we used ANSI escape codes to paint a board on the screen, and we then used the keyboard input from the user to move a cursor location on that board. So for today we want to look at animation. The goal for today is that we'll assign a speed at which the cursor location will move, and then we'll let the user control the direction in which that cursor is moving. So just a reminder of what we did last time. If we now run the application, we get this blue block, and this represents the board. Inside the blue block we've got this smaller white block the size of a single cell, and the user can move that white block around using keyboard input. So to start with animations, we'll first need to introduce the game time. So the game time, that's typically a floating point value because it's easier to do arithmetic with floating point values, and it represents the number of seconds that the game's been running. So to calculate the game time, we'll first need to capture the start time, and we can capture that using the I/O interface from Zeek. So on the clock, we'll just ask the clock now. Now there's a number of clocks that we can use. So we've got the real clock, which would be the system time or the world clock. Now this may occasionally count backward because there could be time adjustments from the admin or an NTP service. The time that's a little bit more useful for us is the awake time. That's the time that the application's been running. So this guarantees that it will never step back, but it may occasionally return the same value on successive calls. So for our game, that's perfectly fine. And the I/O parameter we can get from the init argument. Righto, so next we'll need to find the loop time. So this will be refreshed every time the loop runs. And then we can calculate the uptime, which is the difference between the start time and the loop time. Okay, now we just need to convert the uptime to a floating point value in seconds. So the game time equals to as if64, and then float from int the uptime, and let's say that will be in milliseconds. So now we need to divide that by the number of milliseconds in a second. Float from int is the time ms. Okay, I forgot to say what I expect here. Okay, so it's complaining that the game time is unused. So for now, just to test what we've done, let's print out the game time at the bottom of the board. Okay, so this is a digit, numeric value, and I want 2 points of precision. Okay, let's give that a go. Cool, so at the bottom of the board we can see the game time is incrementing at a rate of 1 for every 1 second. Okay, so let's use the game time to calculate the number of steps that the cursor can take in a single iteration of the game loop. So to do that, I would need to introduce 2 additional values in the game state. So the first, I'm just going to have it as a constant for now, is the speed at which the cursor may move, and I'm going to set that to 3. So in any given second, it will move by 3 steps or 3 cells. Next, I need to keep track of the last time that the cursor took a step. Again, that's going to be a floating point value, and we just initialize that to 0. Then we go to where we update the game state, and here we calculate the number of steps that the cursor can take in this iteration of the loop. So let's just say const steps equals to, and we're going to round and do a little bit of arithmetic here. So if we take the game time minus the time of the last step and multiply that by the speed, then we'll find the number of steps. So in this case, say speed equals to 3. Let's say there's a difference of 300 milliseconds between these two timestamps. So that's going to give us a value of 0.3. So 0.3 times 3 rounds up to 1. Okay, so then if the steps were greater than 0, then what we'll say is that we took a step, and we'll implement the logic for this pretty soon. Okay, now just for our own sanity, let's print out the number of steps. So this should constantly, no, they're not speed. So this should basically alternate between 0 and 1 for all the iterations of the game loop. Let's give that a go. Okay, so as we can see there, it's alternating between 0 and 1. Cool. Okay, so let's put those steps to use. And for that, I'm going to introduce a direction enumeration. Now, the direction enumeration will look very similar to our action enumeration, but there are some differences. And it will become clear in a moment. Okay, so going to our game state, we want to introduce a variable to keep track of the direction. And let's initialize that to up. Then where we process the user input, we need to convert that input to a direction. Cool, so this may look like a bit of duplication, but yeah, it will become pretty clear soon. Okay, so then down. Okay, what I'll also do is I'll move the calculation of the steps down to where we decide what to do with the direction. Okay, I'm going to change this to a variable, and we're going to loop over while the steps is greater than 0. On every iteration we will decrease steps. And let's say steps is an I32. Okay, and where we process the direction, that goes inside the loop. Now, so what's happening here is every time we can take a step, we're going to just reset the last step time, and we're going to adjust the location. Actually, this alt location we can also move over here. Okay, then the last thing we need to do is let's just remove this print statement at the bottom. Okay, let's give that a go. Cool. So there, all we need to do now is the user sets the direction, and then the cursor just keeps moving in the direction at the specified speed. Now at the moment I've got it at a speed of 3, so it's moving by 3 cells every second. Okay, so we can adjust the speed. So if we go back into our application and we find the speed, so let's slow it down to 1 step per second, and we give it a run. Now we can see the cursor is moving much slower. Anyway, I'm going to reset this to 3. Okay, I'm going to stop the video over here. Now this definitely looks much shorter than my previous video, but we did accomplish the goal for today, which was to animate the movement of that cursor over the board. Now what I want to do in my next video is I want to look at painting the body of the snake and letting the body of the snake grow over time. Now, I do think we may need to dabble a bit with raster images to improve the efficiency at which we paint the screen at the end of each iteration of the game loop. Anyway, if you like this video, click on the like button. If you want to see more, click subscribe, and I will see you in my next video. See ya.